About clouds now. So clouds then are the accumulation or aggregation, a fancy word for accumulation of moisture. All right, so we are aggregating condensed water into a particular location in the atmosphere. And when there's enough of that aggregated water that is visible to the naked eye, you and I see clouds. All right, so we're producing these clouds when there's atmospheric instability. And remember, atmospheric instability is when we are lifting air and dropping air. All right, turbulent air that you feel when you're in aircraft is a good indicator that there is transportation of water to some volume which is occurring, right? And we're going to create those clouds at the lifting condensation level. And at that lifting condensation level is where we're going to get 100% saturation, right? The one thing that we haven't talked about is in order to create a cloud, you need something called a condensation nuclei. You need a little bit of a particle, some dust from a volcano, some pollution from a factory, some pollen, some sea salt, something for that water to adhere to. So every little droplet of water that's condensed in the atmosphere in a cloud is associated with some particle of something. So there's lots of stuff in the sky other than just water. The other thing that we're going to talk about here in a few minutes is clouds come in many forms, and clouds are formed by lifting that air to a particular level that allows for the aggregation of condensed moisture to occur. But then they start to take on different shapes. And the combination of shapes and elevation of that cloud then produce the names that we attribute clouds to. And there are many different types of clouds out there in their names, but we're only going to address a couple of them, a few of them. And we will use the Latin, but we'll try to make the Latin palatable for you. Fog is a special cloud. Fog is just a cloud where the lifting condensation level is very close to the surface of the earth. Fog can occur in a number of ways. We're not going to get into all of the ways that I have listed here for the genesis of clouds, the radiation, evaporation, advection, and upslope mechanisms of fog production, but fog is just a low-level cloud. If you can create clouds at high elevations when the temperature is cool enough, at low elevations you're going to produce a cloud at that level. Dew, on the other hand, is the formation, the condensation of that cloud at the surface of the earth, that the cloud precipitates out and interacts with a cold surface. The handrail on stairs, your vehicle, the lawn, is where we get dew production occurring. So cloud structures. 3 types of structures to clouds, really kind of basic, all right? The English is puffy clouds, wispy clouds, and flat clouds. In Latin, we call them cumulus or cumuliform. So form is structure. Wispy is cirriform, and then flat is stratus or stratiform. All right. So most clouds begin as puffy or cumulus, and so think to accumulate. We are accumulating condensed water. And the formation of cumulus clouds are low to mid elevation. All right, I'm not going to have you worry about the numbers, how high above the surface of the earth we are talking about. I just want you to know that they occur at the lower to mid levels of the atmosphere. All right, generally they have a vertical development. So what I mean is that they are taller than they are broader. They often start off like those little cotton ball shapes in the summertime. So think cotton balls, cotton candy, little fluffy shapes. Over the course of days or weeks, those little fluffy balls can grow into larger balls and take on much taller structure. The taller they are, the more energy they have. The more energy they have, the more precipitation they can rain out, but also the more damage that they can do, because every ounce of water that's in the atmosphere is holding a significant amount of energy that can be transferred into a storm. Wispy clouds are mid to high elevation clouds, and what they are formed from is those cumuliform clouds, the cumulus nimbus or the stratonimbus clouds have precipitated out their moisture, and wind has pushed what is left of those clouds out and sort of stretched them out like cotton candy at a circus. So if it works for you, think circus horses with their wispy tails, or cotton candy at circuses. They're sort of that wispy sort of shape. That's a cirrus cloud. And because they're at higher elevations, they're going to be colder. They will have lost a lot of energy, which means they're going to be ice crystals. So cirrus clouds are ice crystals. Flat clouds, stratus clouds, are most often at low elevations to mid elevations, and they don't have a lot of vertical structure, which means they're not piling up a lot of energy. So they're generally pretty stable. These flat stratus clouds are very common to the Youngstown area, particularly in the winter months. And you and I have experienced this if you've spent any time in the Youngstown area, where you can have weeks and weeks of cloud cover. A favorite thing of Northeast Ohio is to say this is one of the cloudiest places in North America, and indeed it's true because of the water that's evaporated off of Lake Erie. But there's not a lot of lift there, and what happens is that we get these very broad flat clouds that are very, very stable. There's not a lot of rotation in the atmosphere, consequently. So in your textbook, there are a number of different illustrations for clouds, and these are the various forms that clouds can take on. So just really quick, here are these stratoclouds. I've got a few here. This nimbostratus, and the typical stratus cloud is what we generally see in the Youngstown area. Summertime formation here, more wintertime formation here. I note it's a little bit higher. Here what's happening is the temperatures just aren't high and are tall enough to lift this, and it's super saturated. The darker the cloud is, the more moisture there is, which is kind of indicative by the condensation nuclei. So we've got lots of moisture with lots of nuclei, which is what you're seeing. So these are flat clouds. You can get these strato, middle elevation, cumulus clouds. So what's happened here is our cumulus cloud maybe precipitated out some moisture, and all we're left with are these individual little balls that are left behind, but they're sort of layered out. They're kind of stretched out horizontally rather than vertically like this cumulus cloud that's here. Our last strato cloud that we've got is sort of a mid-elevation cloud. It generated out of this elevation cloud right here. So you can imagine this cloud, this bottom part of the cloud precipitated out all its moisture. This bit of the cloud remained intact, and wind sort of pushed and stretched out the middle part of this cloud, leaving this sort of structure here. Altocumulus cloud also generated out of this cloud here, but instead of the wind stretching it out, it left it at these little puffballs. So this is happening sort of before it gets stretched out here. Eventually, this stretched out cloud will turn into a stratus cloud. This is generated out of these higher elevations of this cumulus nimbus cloud. And again, we're this cirro, which means they're frozen. So we start out as a cumulus frozen cloud, the wind starts to push it, we get a strato, and then we get a cirrus. So we're accumulating clouds here, and then we generate most of the rest of these, except for these lower two, out of these cumulus clouds. Early day, low temperature generation is this formation right here, when you've got lots of moisture available and lots of heat available to generate a towering cloud, cumulus cloud, or a cumulus nimbus cloud. Then you get this formation right here.